So what's the expression for what is the expression pH is minus log of the concentration of H positive ions. ठीक है, that's easy. What's the K for a weak acid? HA would dissociate and it will produce two ions. One is H plus one, the other one is A minus one. So what is the expression? It's going to be H plus concentration times your A minus one concentration divided by the weak acid concentration. Buffer, we're going to skip. That's another buffer solution. Just a second. Uh, you're being told to figure out the pH of 0.1 mole per dm cube ethanoic acid. So ethanoic acid dissociates and it produces. I'm skipping the organic part and produces these two ions. So your K expression is H plus 1 concentration squared divided by the ethanoic acid concentration. Why is it squared? Because these two ions, it's product concentration. These two ions have exactly the same concentration. They're going to be producing exactly the same amount. So the K value is with us. It's 1.75 times 10 power minus 5. The H plus 1 squared, we don't know. The concentration of the ethanoic acid that's given, that's 0.1. Somebody try and find this out. What is this?
So 1.32 multiplied by 10 to the power minus 3.
Oscar, take the negative
No, it's
log of
after square root. अच्छा अच्छा ठीक है.
under root.
Okay.
How much square root? Take the negative log to figure out what the pH is. आगे, what's the pH? अपान आया कि नहीं आया? What's the pH?
एक सेकंड सर. 2.88.
ठीक है, so the pH is 2.88. So next you have तो ठीक है, एक सेकंड में मैसेज कर लूँ. अच्छा, so we're going to do the next part now, which is most of the questions are related to a buffer solution, right? ठीक है, we know what a weak acid is. ठीक है, ये clear है? Is this clear? Zaira, is this clear? Anam, is this clear?
Yes, sir.
अच्छा, so we're going to do the next part, which is what a buffer is. So a buffer solution, ठीक है, first thing, how does it work? A buffer solution is a solution that's made out of a weak acid and its conjugate base. So it's a mixture of weak acid and conjugate base and its conjugate base. And what does it do? And it resists a change in pH. You have to write this exactly when they're going to ask you about a buffer solution. A change in pH when a small amount of acid or alkali is added. So when a small amount of acid or alkali is added. Now, here's the thing. The important thing is that you've got uh, now reactions are very sensitive to pH. Remember, all reactions are happening in water, right? And I've told you that water contains two ions. One is H plus one, the other one is OH minus one, right? So if they're equal, that means it's neutral. If there are more H plus one ions in the solution, that means you've added an acid, and that would make the solution acidic. And if there are more OH ions, that means you've added a base or an alkali. So you've got more OH ions, and that makes the solution basic. But the thing is that your everyday reactions are very pH specific. ठीक है, almost all reactions are very sensitive to pH. ठीक है, because if you add too many H plus ions in a particular reaction, the reactants are going to get affected. If you add too many OH ions, so every reaction requires a certain balance of H plus one and OH ions. ठीक है, your crops are going to grow well. Every crop has a certain pH. Your stomach has to maintain a certain pH. So the pH should not change. ठीक है, this is what we know, that if you change the pH, reactions, especially biological reactions, they get badly affected. Enzymes get denatured if the pH changes. Okay, so enzymes, etc., all these biological molecules, they work best at a certain pH. So pH should not change, and it should especially not change when you add a weak acid, when you add some acid to it, or you try to increase the concentration of H plus one, or you try to increase the OH ion concentration. The mixture should resist that change. So how is a buffer formed? A buffer is formed when you have two things: when you have a weak acid and you have its conjugate base as well. So for example, I'm going to take ethanoic acid. Okay, I'm going to show you how it acts as a buffer. So if I take ethanoic acid dissociates. Now, naturally, it's going to produce its conjugate base, which is CH3COO minus one ions. So this is my weak acid, and that's the corresponding conjugate base. But normally on its own, ethanoic acid, like if I have 1,000 molecules of ethanoic acid, hardly one molecule of ethanoic ion and one H plus one ion would get produced. So ethanoic acid dissociates very, very weakly. So normally pure ethanoic acid is not going to have a lot of conjugate base. This has to be added. Extra conjugate base has to be added from outside. Because on its own, ethanoic acid is not going to dissociate. ठीक है, remember, this is just right now. We don't know how the buffer works, but I told you that a buffer is a mixture of a weak acid and its conjugate base. So the problem with just adding a weak acid is that it just produces very little conjugate base. So you have to add extra conjugate base from outside. And how do you add that extra conjugate base? There are two ways of doing that. Number one, you either add a salt, add a soluble salt of the same weak acid. Now, if I add a soluble salt of the weak acid, for example, if I add sodium ethanoate, then this sodium ethanoate is going to produce the ethanoate ions. Okay. So that's one way of doing that. I'm going to add sodium ethanoate. So my ethanoate ion concentration would increase. Okay, let's say I add a lot of it, right? Is this clear that you're going to take ethanoic acid and you're going to add extra salt of the weak acid so that the concentration of ethanoate ions goes up? Is that clear? Okay. And the other thing that I can do is I can neutralize some of the weak acid. So some of the weak acid needs to be neutralized. So the other thing by adding NaOH or some alkali. An example is NaOH. So what's going to happen is that since I did have ethanoic acid, if I add a little bit of NaOH to it, then some of the ethanoic acid is going to get neutralized and it will produce the conjugate base. So for example, let's begin again. If I had like ethanoic acid was not dissociating, it wasn't producing the conjugate base. If I neutralize half of the ethanoic acid, so how many molecules are left behind? That's 500, right? And the rest of the 500, I'm adding an alkali, I'm neutralizing the ethanoic acid. So the remaining 500 would turn into the salt, which is sodium ethanoate. So the concentration of the conjugate base will go up. Okay. The pella part clear? Is this the first part? Just the first part. That for so just the first part. That you need two things. You need the weak acid. You need the conjugate base. But the conjugate base concentration it has to be increased by either adding the salt or by neutralizing some of the acid and turning it into a salt so that this ion gets produced. Is this clear? The first part.
Yes, yes, sir.
TK.
Yes, sir.
Remember, we don't know how it works. TK. I just told you that you need two things. Now, the next thing is how does a buffer prevent the prevent a change in pH? So what happens is now your solution has two things. TK, your solution, your container, let's say this is your solution. Now this solution has two things added to it. It's got ethanoic acid, lots of ethanoic acid, and it's got a lot of conjugate base as well. Now, if I try to add alkali or acid to it, it's going to resist a change in pH. So, for example, if I add H plus one ions, what's going to happen is, so I'm trying to decrease the pH. I'm adding more H plus one ions. So one of them is the weak acid, the other one is acting as the conjugate base. Acha, out of the two, who's going to react and neutralize the H plus one? It's going to be the conjugate base. So if I try to increase, like if this is your stomach and you try to you drink something that's acidic, right? The ethanoate ions will quickly bond with the H plus one ions, and they're going to neutralize it, forming CH3COOH. So the extra H plus one that have been added, they have now been neutralized. Is that clear?
Yes, sir.
Okay, so the concentration of H plus one remains exactly the same as it was before. Year apart clear? Is this clear to everyone?
Yes,
Sana, is
sir.
this clear? Akshita, is this uh, um Amna, is this clear? Similarly, what if I try to add an alkali to it? Okay, again, like I start drinking an alkali, right? The stomach is going to try and neutralize it. It's going to resist a change in pH. So it's going to prevent it from becoming alkaline. So you add OH ions. Now, who's going to neutralize the OH ion? It's the weak acid that's going to neutralize the OH ions. The weak acid would start acting as the acid. The OH ions are negative. The positive H plus ions are going to get attracted to it. The acid will go and release H plus ions. So it will become CH3CO minus 1. and the OH ions will get neutralized. The weak acid will release H plus one ions. ठीक है? Is this clear?
यही सर।
और इसका लिख भी दें कि so weak acid over here, it's the conjugate base that's behaving as the acid. So yeah, as the base. ठीक है? So both H plus one and both OH ions they get neutralized if you add it to this buffer solution. The buffer solution is a mixture of the conjugate base and the weak acid. ठीक है? Is this 100% clear how this works? How does a buffer solution work? Clear है
Yes, sir.
कि Masale, everyone is Binayil, is this clear? Afan, Akshita, Zaina.
Yes, sir.
यस सर।
So acha. So remember one thing, okay? What's a buffer? It's a weak acid and the conjugate base mixed together. And it could be any combination. It's for example, I've got the examples of buffer. As long as there's a weak acid and the conjugate base of the same weak acid. So for example, I mix ammonium chloride and ammonia together. Is that a buffer? Though it is a buffer because the NH4 plus 1 can act as the weak acid. It can release an H plus 1. So I've got a weak acid and I've got its corresponding conjugate base as well. So a mixture of ammonia and ammonium chloride will basically behave as a buffer. And how would it behave as a buffer? Because if you add H plus one ions, the solution has two things. It's got ammonia and it's got ammonium ions, right? So if I add H plus one, the conjugate base will come in and will neutralize those H plus ions. And it's going to turn it into ammonium ions. Similarly, if I add OH ions, who's going to neutralize the OH ions? The NH4 plus one, which is my weak acid, that's going to come in. Okay, now remember, these equations are very important because you're going to be asked very, very frequently to make these equations. Okay, so we're going to just practice a few of them. So the ammonium ions are going to come in. The weak acid will release an H plus one. It's going to turn into ammonia. And the H plus one and the OH ions, the OH ions are going to get neutralized. It's going to form water. Okay. So is this clear?
यस सर।
So let's do another one. Let's say I have another buffer. So I've got a mixture of let's do an easy one first. So I've got propanoic acid, C2H5 COOH, and I've mixed it with the conjugate base as well, C2, which is C2H5. They're going to form a buffer, obviously, because one of them is the weak acid, the other one is the conjugate base. So it's C2H5 COH, and it will ionize and it will form the conjugate base C2 plus H plus 1. So these ions are coming from here, and this is over here. And again, I'm going to try and write the equations, which is that if you add H plus 1 ions to it, so who's going to neutralize it? It's the conjugate base that's going to neutralize it. So C2H5 C double O minus 1 is going to come in. It's going to attract the H plus 1 that you're adding, and it's going to neutralize it. तो क्या बनेगा? It's going to form C2H5 C double O H. Similarly, if you add OH ions, so the weak acid will neutralize it. The weak acid will release its own H plus 1 ion, and it will become C2H5 C double O minus 1, and the H plus 1 that's released is going to go and neutralize the OH ion. So both H plus 1 and OH ions are going to get neutralized. ठीक है, just one more example. ये वाला example, is this clear? This one?
Yes sir, बस I have a question कि वो नाइट क्या कहते हैं सोडियम के साथ क्या होगा, like it
नहीं,
shouldn't come in the
sodium, अच्छा नहीं,
equation.
sodium is just a spectator ion. It's not really doing
Okay.
anything. ठीक है, remember
Okay.
when you have sodium salts, when it's an aqueous solution, it will dissociate. So basically the sodium, I mean, think of sodium as something that's not there. I mean, it's just roaming around. ठीक है, it's not doing anything at all. ठीक है, so it's not doing anything. अच्छा, let's do one for an acid salt. ठीक है, for acid salt, it's kind of harder to figure out which one is the weak acid, which one is the conjugate base. So if I have, like, I've got NaHSO4 mixed with Na2SO4, right? So if I mix these two things together, so remember I told you that Na is, I mean, think of, just ignore Na, okay? Ignore Na is just a spectator ion. So basically I've got HSO4 minus 1 ions, and over here I've got the SO4 minus 2 ions. Now the weak acid is the one that's got more H plus 1 ions. It's definitely going to be my HSO4 minus 1 ion, and it will be in equilibrium with SO4 minus 2 and H plus 1. So this is going to be my conjugate base, and that one is basically behaving as the weak acid in this particular equilibrium. Is that clear?
Yes.
Or Baki reaction, it's exactly the same. Like if you add H plus 1, who's going to neutralize it? It's the conjugate base that's going to come and neutralize it. So SO4 minus 2 is going to come in. It's going to grab the H plus 1, and it's going to turn into HSO4 minus 1. And if you add OH ions, who's going to neutralize it? The weak acid, HSO4 minus 1, is going to come in. It's going to release an H plus 1 so that the OH ions, they get neutralized. SO4 minus 2 is going to be produced, and water is going to be produced. ठीक है, so ये clear है? Acid salt, is this clear, this part?
Yes,
Yes
sir.
sir.
अच्छा, moving on. So remember, this is the same equilibrium. The equilibrium hasn't changed. It's exactly, I mean, this one is, you've got exactly the same equilibrium, except that there's one difference now. And that difference is that you pick any equilibrium, it's going to have the same. Remember the K value does not change. So you have the same exact value for K. So the dissociation constant is constant. Only one thing changes the dissociation constant, and that one thing is temperature. So it's etherite ion concentration times H plus 1 concentration divided by acid concentration. Now, there's only one difference. The expression that we were studying for weak acid and now for buffer, same exact equilibrium, same exact value of K. The only difference is that your H plus one concentration and your conjugate base concentration is not the same now. You can't write it as H plus one squared. So these concentrations, these two, because remember you added extra ethanoate ions, right? So the concentration of H plus one and the concentration of CH3CO minus one, they're no longer equal. So is that point clear? That's the only difference that you're going to do in your calculation. Is that clear?
Yes, sir.
Yes, sir.
Okay, so you can't write the numerator as H plus one squared. And the same expression could be written as, I mean, you would see it written as two different things. You can either call it conjugate base. Sometimes it's also referred to as the salt concentration times the H plus one concentration divided by the weak acid concentration, which is okay. So that's the expression that we are going to use for K. That's it. Okay, so that's all. That's buffer solutions. Uh, so only one minor difference, and you have to be very good with writing equations, identifying which one is the weak acid, which one is the conjugate base. So we're going to start doing questions, past paper questions. The ones that we missed out, we're going to try and do those questions now, where there was a buffer involved. So I think we did all of these. KSP, 1 second. Yeah, this one. So remember this question. We did the first part. We didn't do the rest of the question. I'm going to do the first part again. In the first part, it's just a weak acid. Okay, there's nothing added. It's not a buffer. Okay, a buffer is going to be formed when you add the conjugate base as well. So it's just the weak acid. The weak acid would dissociate, and it's going to form H plus one and OBr minus one. It's going to have a K value, which is H plus one. I can write H plus one squared over here, divided by the weak acid concentration, right? The K value is known, that's 2 times 10 power minus 9, TK, and H plus 1 is squared and divide by the weak acid concentration, which is zero point 0.2 mole per dm cube. Can you quickly find out what the pH is for this one?
Sir, 4.698.
4.7, TK, that's your pH.
Yes.
But anyways, that was just the weak acid, right? The next part is the buffer. Remember, I told you how to make the buffer. He's neutralizing the weak acid with KOH, right? With an alkali. What I'm going to do is I'm going to first try and figure out what the reaction is. So I've got HOBr and I've got KOH. They are reacting together. Well, what's the reaction? The acid produces the H plus one and the base produces OH ions. They react and they form water. And what's left behind? It's going to be K plus one and OBr minus one, right? And you'll have water that's going to be produced. Now, can you tell me how many moles of QH do we have? Like how many moles of KOH are being added? 5 into zero point 0.2 divided by 1,000.
Sir, 1 multiplied by 10 to the power minus 3.
So I've got 1 times 10 power minus 3. Okay, so that's 0.001. How many moles of HOBr do you have? Same
4
concept.
multiplied by 10 to the power minus 3.
Okay, so that's 0.00. 4 moles, right? Okay, so which one is in excess? 0.001 will completely react. And it's going to react with how much? 0.001, right? So that means 0.003 moles will be left at the end of the reaction, right? But is that clear? 0.001 will react with 0.001 and it will end up producing how many moles of KOBr it's going to produce? 0.001 moles. Is this clear?
Yes, sir.
So what is left at the end of the reaction mixture? So you've got your solution now has the conjugate base, which is remember K plus 1 is just a spectator, so it's got OBr minus 1 and the moles are what? 0.001. It's got the weak acid as well that's left behind, so that's HOBr. And the moles that are left behind are 0.003. Okay, so it is a buffer, right? Because you've got the weak acid and you've got the conjugate base as well. So what is the expression now? I mean, it's the same expression. It's the same K expression for this reaction. You have exactly the same equilibrium except with one difference, and that is that you can't write H plus 1 squared because OBr minus 1 is a different concentration because it got neutralized and it got produced, right? So my K expression would be H plus 1 concentration times OBr minus 1 concentration, which is what? 0.001 divided by my HOBr concentration, which is what? 0.003. And I don't need to find concentration even. I can directly use moles over here because what you need to do if you want to convert moles to volume, what you need to do is you need to divide by volume, right? So if you divide by volume on top and divide by volume at the bottom, the volume term would get cancelled out anyway. So there's no point finding concentration. You can plug in moles directly over here. The K value is given. It's already known. Okay, the K does not change. So that's 2 times 10 power minus 9. So can you figure out what the pH is? The H plus 1 would be, it will become 3 times 2 times 10 power minus 9. Like it's 1 over 3, right? So what is the pH now?
Sir, 8.22.
Okay, so your pH is 8.22, right? Okay, so it's coming out to be 8 point. 1 second. That's our answer. But is this question clear that he took a weak acid, did not fully neutralize it, neutralized some of it so that the conjugate base OBr minus 1 got produced. 0.001 moles ended up producing 0.001 moles of OBr minus 1, and there was 0.003 moles of HOBr that's still left in the reaction. So your mixture was a mixture of conjugate base and the weak acid. And they're going to have the exact same equilibrium. Weak acid with the conjugate base, they'll form the same equilibrium, except that the concentration of these two ions are not going to be the same. We are getting OBr minus 1 from somewhere else. And you're going to plug in the values and you're going to find pH. TK, your question, is this question clear to everyone?
Yes, sir.
TK, so another one, similar question. This I think the second part, this is the one we did an example for this. This is the ammonium ions in equilibrium. We did the first part early on. In the first part, it's just ammonium ions. The chloride over here is just a spectator ion. It's not doing anything. Okay. So you've got 0.3 mole per dm cube. Now, if I write the K expression for this, it's the same expression. It's going to become H plus 1 squared since it's not a buffer at the moment. It's the solution just contains one thing, and that's ammonium ions. So that means these two ions will be produced in exactly the same amount, and it's going to be H% squared divided by the ammonium ion concentration. And he's asking us to figure out, uh, he's basically asking us to figure out the H% concentration, the Ka value. The pH is given, that's 4.89. So if the pH is given as 4.89, what is your H+1 concentration? That's going to be 10 raised to the power minus 4.89. Is that clear?
Yes, sir.
So this is 10 raised to the power minus 4.89 squared. And we're going to divide it by the ammonium ion concentration, which is given over here. That's 0.3 mole per dm cube. So what is the Ka value that you're getting?
5.53 multiplied by 10 to the power minus 10.
And what is pK that you're getting? Take the negative log of this. What do you get?
9.25.
So you're getting 9.25. Anyways, now he says that explain with the aid of an equation how the solution can behave as a buffer when a small amount of a strong acid is added. And the second part, if you add a strong base. Okay, so remember these equations, they're very frequently asked. So what happens if so you had two things. You had ammonium ions and you had its conjugate base. So if I add a strong acid, I add H plus one ions. Who's going to react with the H plus one ions? Who's going to neutralize them? कौन होगा?
N NH3?
ठीक है, so it's NH3. It's the conjugate base that's going to grab hold of the H plus one ions and it will turn it into NH4 plus 1. So the H plus 1 ions are going to get neutralized. And if you add an alkali to it, a strong base to it, then the ammonium ions, the weak acid, will release H plus 1 ions and it will lose the H plus 1. The H plus 1 is going to go and react with the OH ion and they'll form water. ठीक है, is this clear?
Yes.
Yes,
Now,
sir.
so ठीक है, that's KW, forget that. Um, this one is just a weak acid, not a buffer. ठीक है, let me see questions. That's KP, forget KP. This question, ठीक है. So this question is going to take a very long time. Uh, ये ना homework है. Try and find out. I mean, this is a very challenging question. Uh, no extra information is required. I mean, it's basically the same. It's a very similar type of question, the one that we did. You have to do the same thing, except that it's kind of linked with moles. There's a lot of moles, and at the end of the day, you have to figure out. Basically, what you have to figure out at the end of the day is once all of this reaction happens, what is the weak acid and what is the quantity of the weak acid that's present at the end? And what is the conjugate base that is formed? And what is the quantity of the conjugate base? If you know that, you can figure out what the pH is. Okay. So we'll do this question tomorrow. Okay. Abhi फिलहाल I'm gonna post this over here. Try, this is a bit challenging. Okay. So try and find out if you can solve this one. Okay, clear?
Okay, sir.
So I'm sending this in the group. Okay, make sure you try and at least attempt this. Okay. Yeah. Okay, then take care. We'll continue next time. Okay.
Okay, sir.
Thank you, sir.
Okay,
Okay,
take
sir. Allah Hafiz.
Allah Hafiz.